Today we'll be looking at finding the volume of shapes which are not prisms. So we'll be looking at the cone, the pyramid and the sphere. And this at the back is half a sphere. It's called a hemisphere. Alright, so we'll start off with the volume of a cone. As we can see, a cone has a circular base and it comes to a peak at the top. Okay, so what is the formula for a cone? The formula for the volume of a cone is 1/3 base area, or times base area, multiplied by the perpendicular height, or the vertical height, how tall it is. Why do we call it vertical height? Which is this here, we call it H. Why do we call it H, or vertical height? Because there is also something called a slant height, which is this here, which we'll see a little bit later on. Alright, so what is the base? The base is a circle. So what's the area of a circle? The area of a circle is pi r squared. So that's 1/3 pi r squared times the vertical height, which we've already named h. The radius is obviously the radius of this circle at the base. We can just call that r here. Okay, and we can see this is a vertical height, which means it makes 90 degrees with the base. We're thinking in 3 dimensions now. The volume of a pyramid. Now, pyramid doesn't have to particularly be like the one I have here. This pyramid has a square base. Okay, not all pyramids have a square base. Maybe it has a triangular base. Maybe it has a rectangular base. Okay, the height is from the ground to how tall it is perpendicularly. Okay, so how tall is this pyramid? Not how tall this slant height is here. Right, so we're looking at the vertical height, just like we did for the cone, the vertical height. Okay, so the volume of a pyramid is exactly the same formula, or the same method, is 1/3 of the base area times the vertical height. Okay, now, where does this formula come from? It's actually, it can be proven that if we find the area of 3 cones or 3 pyramids, they will actually come to the area of a cylinder, which is pi r squared h. That's the volume of a cylinder. So 3 of them will make 1 cylinder. And that's where it comes from. So it's 1/3 of that. Okay, let's go on and see a problem or an example. Okay, so the first example says find the area of this rectangular based pyramid. We can see a pyramid here. It has a rectangular base 10 by 8. We know the volume of a pyramid is the same as the volume of a cone. It's the third volume equals 1/3 base area times height. Well, it's not exactly hard to find the area of a rectangle. So 1/3 times the base area, which is 10 times 8, or 80, times the vertical height. So coming from this vertex up here, exactly landing right in the middle here, we have a height of 12 centimeters. We multiply that all together, or do it on your calculator if you like. You should come to 320 centimeters cubed. Next example, find the volume of this cone. Okay, we have a vertical height of 12. We can see right across here it's 10 centimeters, which means the radius must be half of that because that's the diameter. So I know immediately that the radius on this is 5 centimeters. Okay, so the volume of a cone is 1/3 base area. So volume equals 1/3 base area, which we know is a circle. So that's pi r squared times h, which is 1/3 pi radius squared times 5 squared times the height. I usually just calculate these first. I say 1/3 times 5 squared times 12, and that will come to 100, and then I hit pi on my calculator, so it's 100 pi. So I can actually work that one out in my mind even. I know that pi is 3.14. If I multiply 3.14 by 100, it will come to 314. Sorry. However, I will do that on my calculator, and it will come to 314159, which to three significant figures is 314 centimeters cubed. So that's the second example done. Let's move on. Right, example 3. Find the volume of the cone with radius 6 centimeters. They've given us the radius here, which is 6 centimeters. I can actually put that in here. That's 6. They've given that to me. And I know here the slant height is 10. Okay, but I don't really want the slant height. I need the vertical height here. So this is an obvious, because that's vertical. That's obvious right angle triangle, because these are perpendicular to each other. So I can use my Pythagoras here to actually find this height. If I don't know that this is one of the standard triangles, I can just work it out. So I know the two perpendicular sides squared and added will come to the hypotenuse squared. Okay, so we're careful here. You can call this x if you actually get it confused with hypotenuse, because that's an h2. But it's the vertical height we're finding. So h squared equals 10 squared minus 6 squared. So h squared equals 100 minus 36 is 64, or do it in your calculator. So h is a square root of 64, which is 8 centimeters. So I found that this here is 8. Okay, now I'm ready to find the volume, just in exactly the same way as I just did in the last question. Volume equals a third base area. I like to write my formula first, pi r squared h, which is 1/3 pi times 6 squared times h. Whoops, I know my h, don't I? So I'll just rewrite that, sorry. Right, that's an 8. Okay, in my calculator, I will do 6 squared times 8 divided by 3. I won't put the pi in for now. And I will come to 288 pi. I then just multiply my answer by pi times pi, because I have the 288 in my calculator, 904.7787, which to three significant figures. I now round it. I want my previous answer before I've rounded it, just to show that I know what I'm doing. And just in case I've made a small mistake, I won't lose all my marks. I'm also less likely to make a mistake. We've said this many times, right? Okay. So that's the volume of that cone. The volume of a sphere. The volume of a sphere. Okay, now a sphere, believe it or not, also has a radius. This radius is going across here like this. Okay, so that's my r. And the radius of a sphere is given by the formula 4/3, which is 1 1/3, pi r cubed. And to find the volume of the sphere, I just have to input that radius. There's no height, basically. If you think about it, if you wanted to know from one side to the other, it's just two radiuses, really, isn't it? Okay, so the next example is asking me to find the volume of a sphere which has a diameter of 8. So right across here is 8, they're telling me, which means that the radius must be 4 centimeters, obviously. Right, so my volume is 4/3. I write my formula first, which is 4/3 pi times 4 cubed. I'll put that into my calculator. I'll put 4/3 times 4 cubed, and it will come to 256 pi over 3, which is 268.08. And now I'm going to round it to three significant figures, 268 centimeters cubed. So all is good, nothing too complicated. Just put it in your calculator, put it in your, plug into your formula, your radius, and just put it in your calculator, let it do the work for you. That's example 4. Calculate the radius of a sphere which has volume this time of 500 centimeters cubed. So this time I know the volume. I put the information I know, which is the volume, which is 500. I plug in my formula for volume, so I replace that V with 4 over 3 pi r cubed. That's equal to 500. I then need to try and isolate r cubed by itself. So the 3 needs to go to the other side. It becomes a multiplication. And the 4 and the pi, which are stuck onto the r cubed, they're multiplied, need to become a division. I can do that all in one go, but right now I'm just going to do it one by one, just for those who don't like to do it all in one go. So I'll leave that. I'll just take that 3 up, which is 1,500. Or if I like, I'll just recopy it as it is. And I will take that 4 pi underneath. So r cubed would equal that, and the r will then be it will come to 119.366. But what I will do is I will just say, okay, what is the reverse of r cubed? What is the reverse of r cubed? Do you remember? The reverse of the inverse of r squared is the square root. The inverse of r cubed is the cubed root. So you can actually get an answer on this, which will be 119. I'll put the answer there, why not? 119.3662. It's still in my calculator, so as it's in my calculator, the reverse of r cubed, I will just hit the cubed root, which is actually shift square root. It's just above the square root button of 119.3662. Okay, if you hit shift square root answer, it will put your last answer in, which was this 119. So you need to hit that answer button and it will put it in there, so you don't manually put that in your calculator in case you make a mistake. So r equals 4.923725, which is in fact 4.92 to 3 significant figures. There you go. Example 6, it gets a little bit more difficult, but not really difficult. Okay, so I'm trying to find the volume of this shape here. Okay, a cone is attached to a hemisphere. Hemisphere, we've said, is half a sphere. So obviously half a sphere will have half the volume of a full sphere, because volume means how much fits inside. So if I'm filling up only half a sphere, then it can only fit half as much as a full sphere would fit in. So a cone is attached to a hemisphere of radius 4. So they've given me this radius here. This is 4, which means, as I can see from the diagram, the cone will also have a radius of 4. If the total height of the object is 10, find its volume. Now they've told me the total height is 10. So I know that if this is the radius, it's the radius all the way around. So it's also the radius down here. Yeah, so if I do a vertical line here, if I make a vertical line, that will also be 4. And if that's 4, we know it's all 10 because they just told me it's all 10. That's the whole thing is of height 10. If 4 centimeters has taken up this bit on the bottom, then that must leave the top to be, sorry, I can't hold this camera very easily. Okay, that must leave the top to be 6 centimeters here. Right, so that's 6 centimeters here, and that bit down there is 4. Right, so we'll start off with the hemisphere. So the volume of the hemisphere is half the volume of the full sphere. So it's half times 4 over 3 pi r cubed. Then I just plug in that radius, which I know is 4. And it's time for my Casio to get working. So I will do a half times 4 over 3 times 4 cubed in my calculator. It will come to 128 over 3. And then I just multiply it by pi. Okay, the final answer is 134.0412. but that's actually rounded, isn't it? Because pi is a never-ending number. It's irrational. So this will actually be my most accurate answer. It's not a final answer, so I continue. I'm trying to find now the volume of the cone. The volume of any cone is 1/3 base area pi r squared times height, which is 1/3 pi. We said that already the radius is 4 times 4 squared times, we said the height is, we already found that out, is 6. In my calculator, I will put 1/3 times 4 squared times 6, and I will end up with 32. So that's 32, and don't forget the pi. Anything circular is going to have a pi in it, remember. Okay, so that's my most accurate answer. If I actually put that in my calculator and want to see how much it's worth, which is about 32 times 3.14, it will come to 100.53, blah, blah, blah. Okay, now for my total volume, I will have to add those together. So I'll have to add, this is my most accurate answer. I prefer to put that, and I prefer to put this, because they're my two most accurate answers. If I put these two, it will still be correct. I just have a habit of putting the most accurate ones in, because we all like maths and we all like to be accurate, right? So let's add them together. So I'm going to say 32 pi plus, I can actually call that 128 pi over 3, because the pi is beside or on the top. It's never on the bottom, yeah, because multiplied by pi means it goes on the top with the numerator. Okay, so I put them together and my total volume will come to 234.572, which is 235 centimeters cubed to 3 significant figures. Okay, that's that. Let's move on now. Let's move on to this last question, which actually has nothing really that complicated in it. We now have a similar shape here to the previous one. It's just we actually have something in the middle here. We have this cylinder, which is actually a prism, isn't it? Remember? Right, so a toy consists of a cylinder of diameter 6 centimeters sandwiched between a hemisphere and a cone of the same diameter. If the cone is of height 8, so we have a height here of, oh, which one's 8? Hang on, sorry. Cone has a height of 8, so that's this bit here. It's a height of 8. The cylinder has a height of 10. And that's it. Find the total volume of the toy. Have they told us at all what the diameter toy consists? Oh, it's 6 centimeters diameter. So all the way across here is 6 centimeters. If it's all the way across 6 centimeters, then obviously the radius must be 3. I can put that there and there if I want. Right, so let's find the total volume. Let's start with the volume of the cone since it's at the top. Volume of the cone is 1/3 of the base area, pi r squared, times the height. So 1/3 times pi r squared, pi times 3 squared times the height of 8. And if you put that in your calculator, it will come to 24 pi. That's a lovely number. The volume of the cylinder will come to pi r squared. Base area of any prism, it's the base area times the height, so the vertical distance between the two cross sections. So the cross section is a circle, pi r squared times the height of the cylinder. So it's pi times 3 squared times the height of the cylinder, remember, is 10. So I can even do that in my mind, really. 3 squared is 9 times 10 is 90 pi. And the volume of the hemisphere is half the volume of the sphere, which is half times 4/3 pi r cubed. So that's a half times 4/3 pi times the radius, which is 3 cubed. You can put that on your calculator, or it could be even nicely more challenging if you do it in your mind, because that's 27 divided by 3 is 9. So we have a 9 on the top. 4 divided by 2 is 2. 2 times 9 is 18. So that's 18 pi. Or just put it on in your calculator. Now the total volume will be the addition of all those three. So total volume will be 24 pi plus 90 pi plus 18 pi. So I can just actually say 24 plus 90 plus 18 pi. I can put that like that if I want. Or I can write them separately. 24 pi plus 90 pi plus 18 pi. If I add all these up together, it will come to 132 pi, which is 414.69 using my calculator, which if I round it to 3 significant figures is 415 centimeters cubed. For now, that's all, folks. Bye.